Question number 6. From the lot of 30 bulbs, 6 is defective bulbs. Okay. Now we have to draw a sample of 4 bulbs. Okay, at random with replacement and find the voltage distribution of the defective bulbs. Okay, distribution of the defective bulbs we have to identify. That means defective bulbs, how many we are drawing? 4. That means we have X will take 0, 1, 2, 3, and 4. This is a random variable because your defective bulb may be 0, 1, 2, 3, and 4 also because we are drawing the 6 one. Okay, now for this X is equal to 0. So first we consider from the sample of 30, we have 6 is defective bulbs and this is, I am writing the defective, and 24 is non-defective. So the probability of D, that is defective bulb, is 6 by 30 and the probability of non-defective bulb is 24 by 30. Okay. Now the bulbs for X is equal to 0. We have X is taken as a value 0, 1, 2, 3 and 4. Okay, for X is equal to 0, that means non-defective. So all the 4 bulbs are non-defective. All 4 are non-defective. That means the 4 bulbs for the first bulb, this is 24 by 30, 24 by 30, 24 by 30, 24. So we have 256 by 625. Now when take X is equal to 1. So for 1 defective and the 3 non-defective bulbs, so there may be option. First is defective and remaining 3 is non-defective. This is non-defective. This is also not defective, non-defective ones. Now first is non-defective, remaining second one is defective, third these are non-defective. Similarly, first 2 is non-defective, third one is defective, this is non-defective. Similarly, first 3 is non-defective and this one is defective. Okay, so the probability is 256 by 625. Okay. Now for X is equal to 2, that means 2 defective and 2 non-defective. So now it will get changed from the 2 defective to non-defective. First is defective, first is non-defective, remaining 2 is defective, fourth one is non-defective. Similarly, first 2 is non-defective, last 2 is defective. First is non-defective, then defective. First is defective, second is non, third is non, and this is defective. Similarly, and this term is defective, first is defective, remaining 2 is non-defective, fourth one is defective. Similarly, first is non-defective, second is defective, third is non-defective, and this is defective. So these are the probability, and or this is option is given. So or we are using plus sign, plus symbol. This is or because option is there. Either any one of the option is true. Okay, either this, or this or option is true. So you will get the probability is this one. Okay. Now for X is equal to 3. For X is equal to 3. So 3 defective and 1 non-defective bulbs. Okay. So 3 defective, that means first 3 may be defective, fourth one is not. First 2 is defective, third one is not, fourth one is defective. Here first is defective, second is non, remaining 2 are defective. Okay, here is first is non-defective and last 3 are defective. So the probability is this one. So for X is equal to 4, all defective bulbs. So we have the first defective, second defective bulbs, third defective bulbs, and fourth defective bulb. So probability is 1 upon 620. When you multiply, you will get this one. Now we have to record this in the probability distribution table. So for X is equal to 0, 1, 2, 3, and 4. So for X is equal to 0, we have 256 by 625. 1, 256 by 625, 2, because these are the probability. So this is the probability distribution, and the answer given in the textbook is incorrect, so you can correct that. Okay. Now question number 7. A biased coin is biased so that the head is 3 times as likely to be occur as tail. Okay. If a coin is tossed twice, find the probability distribution of number of tails. Okay. So here it is already given a coin is biased. Biased coin means what? The probability of head and the probability of tail is already given. Okay, already specified. In general, we are taking the probability of head as 1 by 2 and the probability of tail we are taking as 1 by 2. But since it is already specified, the coin is biased. Okay, so coin is biased means that means the probability is already specified. So it is written that biased coin 3 times head. So head is 3 times as likely as occur as tail. That means when the head is suppose we have the 4 times toss. In the 4 times you will get 3 head and 1 tail. This is already specified. That is given in the question. Okay, because the coin is biased. So the probability of head is 3 by 4 and the probability of tail is 1 by 4. Okay, a coin is tossed twice. That means we have to toss a coin 2 times. So x can take value 0, 1 and 2. So when x is 0, okay, we have to identify the probability of tail. That means when x is 0, that means no tail is occurs. So the probability is 3 by 4 and 3 by 4. Okay, because no tail, that means the which number is out, which number will come, head will appear. So the probability of head, that is 3 by 4 into 3 by 4, 9 by 16. One tail and the remaining head. So this is the probability of head and this is the probability of tail. Similarly, the first coin may be show head, tail, and second coin will show head. Okay. Now third one, that is probability of x is equal to 2. That means both the coin will show tail. So this is tail and this is also the probability of tail. Okay, 1 by 4 and 1 by 6. So now this will be the probability of number of tails when the two coin is tossed. Okay. So we can represent this probability in the table. That is for x is equal to 0, we are getting 9 by 16. And for x is equal to 1, we say 3 by 8, and x is equal to 2, we have 1 by 16. So this is the probability distribution of number of tail when the coin is biased. Okay. Now the question number 8 we have. In the question number 8, we have to identify the probability distribution of a random variable x. Okay. The probability random variable x has the following probability distribution. So x is 0, 1, 2, these are the probabilities given. So first of all, we have to identify the values of k. Then we have to identify x is less than 0 and x is greater than 4. X is less than 3 and x is greater than 4. Okay. Since we know that it is the probability, sum of all the probabilities should be equal to 1. That means for P of 0, P of 1, P of 2, P of 3, P of 4, P of 5, P of 6 and P of 7, which is sum is equal to 1. So you can add the corresponding probability, that is for 0 plus this plus this plus this. All this term you will add and this term. Okay, then this total sum will equal to 1. So when you simplify that one, some term will get cancelled, you will get this quadratic equation. Okay. So you will get this as a quadratic equation, that is 10k square plus 9k minus 1 minus 1. So when you simplify this one, you will get the quadratic equation. So 10k, from in this pair you will take 10 common, 10k common, and here you will take minus 1 common. So here you will get 10k bracket k plus 1, then minus 1 bracket k plus 1 is equal to 0. Then k plus 1, second bracket 10k minus 1 is equal to 0. So this is the probability. Okay, so you will get the k is equal to 1 by 10. Okay, now we can substitute this probability in the table. Now the second term we have to identify the P of x is equal to if P of x is less than 3. So for x is equal to 0, x is equal to 1 and x is equal to 2. Okay, for x is equal to 0 for this plus this plus this is given. So total is what? 3k, but k value 3k, but 3 into k is 1 by 10. So that answer you will get 3 by 10. Okay, so the probability of this term is 3 by 10. Now for x is lies between probability of x is lies between 0 and 3. That means x is greater than 0. That means 1, 2, and x is less than 3. That means 1 and 2. So we have to calculate the probability of x is equal to 1, x is equal to 2. So I can add here, this is k plus 2k, so that is 3k. So again 3 into 1 by 10, that is 3 by 10. Okay, this is the probability. Okay, so go through this video and try to solve the sums. Okay.